You grab your iced coffee, walk over to the condiment bar, and there it is, the modern moral test. Sitting right next to the napkins, you have to choose between a conventional plastic straw and a paper one. Most of us feel a deep-seated guilt when we see a plastic straw. We've been conditioned to associate that single-use tube with marine pollution and the specific risk it poses to wildlife. So you reach for the paper straw. You endure the sogginess, the weird cardboard taste, and the structural collapse halfway through your drink, accepting it as a noble, necessary sacrifice for the health of the planet. But is that eco-friendly guilt trip actually a chemical bait-and-switch? By attempting to solve a highly visible waste problem, well-intentioned consumers have unknowingly introduced a new set of invisible chemical variables into their daily routines. Think about the physical mechanics for a second. How do you prevent a tube made of paper from instantly dissolving when submerged in liquid? Manufacturers use per- and polyfluoroalkyl substances, or PFAS, to solve this. These chemicals act as a water and grease repellent, essentially waterproofing the hydrophilic paper fibers. This chart shows PFAS prevalence in popular green alternatives. Researchers found it in 90% of paper straws and 80% of bamboo straws. Stainless steel sat at 0. The specific compounds detected, like trifluoroacetic acid, are highly soluble in water. Because they dissolve easily, these chemicals can leach directly from the straw into the beverage you're consuming. This creates an environmental irony. PFAS are famously resilient, often called forever chemicals, because they resist breaking down. Their presence means these paper and bamboo straws are not actually fully biodegradable. A paper straw functions as a delivery system for industrial chemicals directly into the beverage stream. This leads many consumers to bioplastics, like PLA. These are marketed as a compostable middle ground that performs like plastic but originates from plants. However, these plant-based materials still shed microscopic debris directly into consumer drinks. In lab simulations, both standard plastic and PLA straws released between 70 and 85% of their total microplastic particles within the first 5 minutes of use. This initial release is mostly manufacturing debris left over from the cutting process. But bioplastics have a specific chemical vulnerability that standard plastics don't, a process called acid-catalyzed hydrolysis. When PLA is submerged in an acidic drink like cola, the low pH fractures the polymer bonds, causing the straw to shed even more microparticles. Heat acts as an accelerator, breaking the material into smaller nanoplastics that are more easily absorbed across human cellular membranes. Switching to bioplastics shifts the problem from mechanical wear to chemical degradation triggered by the acidity of the drink. Based strictly on the toxicological and environmental data, what is actually the safest choice? Out of all tested materials, stainless steel was the only one completely free of both PFAS contamination and microplastic shedding. If you've been choosing paper or PLA straws, you are acting on the information available to you. The entire system is incredibly complex, and those choices were driven by a genuine desire to reduce plastic waste. The straw movement highlights a common sustainability fallacy, searching for a one-to-one disposable replacement rather than addressing the underlying throwaway habit. If our well-meaning fix for a single plastic tube revealed a hidden toxicity, what other eco-friendly compromises are hiding in plain sight in our daily lives?